Hello guys, welcome back to this wonderful platform GradeUp, and today we are here to discuss a topic from Material Science Engineering Services paper 1 as well as technical paper both. So guys, this topic is going to be a part of ESC paper 1 for all the branches, and it is also a part of Material Science for mechanical engineering students technical paper. And the discussion what we are going to do this time, all of you have studied in the first year of your engineering physics subject. The topic is Miller indices, but the reasons for Miller indices comes under material science. You have studied that what is Miller indices, but why it was introduced you have not seen. That comes under material science. Good morning Tirumalai, Gaurav Vajpayee, good morning. So guys, today we are going to start with this. Yes. So, yes Sajal, I am fine dear. So guys, today the discussion is going to be based upon Miller indices, and this is so important topic that for engineering services paper 1 as well as technical paper, in both it comes. So it is more important than other topics what we have discussed till now. Numericals may also come from this, theory may also come from this. So today's and next session, which is on tomorrow, they are specially most important session for the subject. Yes, GR Giri, hi dear. So guys, just quickly share the session with your friends, subscribe the channel so that you can also have all the notifications for the further new sessions also. Chanti Yadav, good morning dear. So as I said my dear, a small announcement is there, then only I will start. That Vision 4 batch already been started from 15th of February. 5th batch will also be coming after April. So guys, this is in April. So 4th batch is already running. So my dear, 3 batches have already been launched before this 4th batch. So successfully they are running, and these are the features, various features, because we have limited number of seats in every batch so that you can attend the live classes properly. There is no problem should be there. A number is already fixed. Okay, so that's why we are launching different batches at different durations. These are the features which you will never get in any other, because this is the platform which provides you the structured courses. And guys, this is the number on which you can ask for any admission related queries. So guys, now I am going to start the session. This was just a small announcement for all of you. And you know that under GradeUp Super, once you are going to subscribe, you can have access to any of our batches, like ISRO DRDO batches are going on, ESC crash course is going on, paper 1 classes are going on, GATE 2022, 2023, ESC 2022, 2023, all these batches are going on. Any batch of your choice, even all the batches you can enroll into. This will be totally your choice. Good morning, A. Yadaya. Okay, so let us move guys. So today we are going to discuss about the Miller indices. And before going to Miller indices guys, I am going to introduce another thing that is known as the planar density. Just try to understand properly. Guys, my first concern is going to be about planar density. What is planar density? What is planar density? So my dear, from this many questions have been asked in definition as well as from numerical parts. When we are talking about planar density, my dear, it is defined as average number of atoms. It is defined as average number of atoms whose centers are intersected by the plane to the area of the plane. So my dear, in other words, you can say it is going to tell you the density of atoms in a specific area. Okay, and my dear, when we are going to find out the density of atoms in the specific area of a plane, basically we have already seen the density at the volume level. Now we are going to see the density at the planar level. Deha Pandey, good morning. So when we are going to see this guys, if I make a unit cell in front of you, then my dear, if this is a unit cell, you know one thing that in this unit cell there are different kind of planes possible. Like if I say this is x direction, if I say this is y direction, if I say this is z direction, then for different planes, like there is a plane called as ABCD plane. There is a plane called as ABCD plane. If you ask me the area of this plane, I will say the area of plane ABCD is going to be a square if the side of the cube is a. Okay, every side of the cube is a. Then my dear, you can have a different type of plane. That plane is this plane, and this plane is nothing but, let us say the name is ABCDEFGH, let us say. So my dear, in that case the name of the plane is going to be AFGD. If you say the plane AFGD, if you see this side is going to be root 2a, this side is going to be a, the area will be root 2a square, my dear. Similarly, my dear, if you see plane, there is another plane. That plane can be shown like this, This plane is DGE, plane DGE. If you see this plane, guys, all the sides are root 2a, root 2a, root 2a. So it is an equilateral triangle. For equilateral triangle, when you are going to find out the area, guys, Neha sir, material science का daily लगे class please. Yes dear, don't worry, अब daily ही होगा. Actually before that I was quite busy, so I have to keep rest for some days, but now it will be going to be continuously, don't worry. J Kumar, good morning. Akshay Singh, good morning. So my dear, now when you will be finding out for DGE, it will be coming out to be root 3 by 2 a square, because you know the area of equilateral triangle is given as, you can find out every side is root 2a. So when you will be finding out root 3 by 2 into square root of 2a ka square, you will be getting this. Okay guys, so this is going to be the area for this plane. So I have written the different planes areas. My dear, if you see individually areas of the plane, it is different for all. So these are the three types of plane which are present in a unit cell. So my dear, for three types of plane you got three areas. Obviously for all the planes the average number of atoms are also going to be different only. So my dear, that is for sure. The number of atoms are different, the area is different, density will also be different. So my dear, we have taken all the possibilities. If you see any plane in this unit cell, you will be getting any one of these plane. This is, let us say, one type, second type and third type. So you will be getting only these three types of plane, with which one is having area a square, other is root 2a square, third is root 3 by 2a square. But my dear, in a unit cell there are many other planes are there. They will be out of these three types only, but they will be there. So many planes of type A, B, C, D are present. Like if you see plane B, F, G, C, area is a square. If you see plane E, F, A, E, area is a square. If you take plane A, E, H, D, area is a square. So my dear, there are many planes of one type. So my dear, many planes are of this type, many planes are of this type, many planes are of this type. So my dear, if we find out the density in all the three types, then also we need to have a arrangement, we need to have a method by which we can identify which type of plane it is. So my dear, if arbitrary you see any plane, you must have the idea that in which category it lies. For that, my dear, Miller have given a number to identify a plane, that if you see one plane, you just write a number by looking at its location, by looking at its position with respect to origin. And if you find it to be a specific type, when you will be giving a number to it, that number will help you to identify that in which category it is going to be. So guys, we are starting with the wonderful Miller indices. Just after learning that, you will be able to identify the types of plane and in which category that plane will be coming, and by finding out the category, you will be able to write down the density of atoms on that plane. So let us continue guys with this. So my dear, if we say Miller indices, how they are going to define? Miller indices of planes are defined as the rationalized reciprocals of fractional intercepts. Rationalized reciprocals of fractional intercept. I am writing it. It is rationalized reciprocals of fractional intercepts along three crystallographic axes. You know there are three crystallographic axes, X, Y and Z. So my dear, they are fractional intercept, reciprocal, rationalized. I will be showing you how to find out Miller indices. I have written rationalized reciprocal intercepts, rationalized reciprocal of fractional intercept along three crystallographic axes. This is how the definition is there. So my dear, if you want to write down now, I have written all the definition in this format, and we will be showing the Miller indices in the small bracket without any separated comma. So it is denoted like this, HKL. This is how we denote, my dear, the Miller indices, HKL without any separating comma. And my dear, if you want to learn how to show the Miller indices, if you want to see how to show the Miller indices, my dear, let us consider one plane. I am taking the plane ABCD for the reference. So my dear, I am taking the plane ABCD for the reference. Once you are going to take plane ABCD for the reference, you know that if you see about x-axis, y-axis, z-axis, I am taking this to be x, this to be y and this to be z. So my dear, if you see about x-axis is going like this, plane is going like this. You can feel the plane is parallel to the x-axis. And you know two parallel things meets at infinity. So my dear, if you see x-axis and this plane, they are going to meet at infinity. So my dear, when they will be meeting at infinity, x-intercept of plane ABCD is nothing but infinite. So my dear, if you see about the y-intercept, y-axis is going like this and plane is also going like this. So they are again parallel to each other. So my dear, they will also be touching each other at infinite. So y-intercept of the plane is also going to be infinite. Now my dear, when we see the z-intercept, obviously when the side is A, the z-intercept is going to be A. But my dear, for making the calculation simple, we will be considering A to be 1 unit. Otherwise, when we are going to find out A, it is coming out to be very complicated number. It is coming out to be like 1.678325, like that, a big number into 10 power minus 10. So it is not good to write every time the value of A. Rather than that, we will be assuming it to be nearly equals to 1 for making the calculations easy. So guys, when you will be taking it 1, you can see the z-intercept is going to be A, and if you are considering A to be 1, z-intercept will be 1. So my dear, this is how you will write the intercept of any plane. So when you write intercept of this plane like this, my dear, just take the reciprocal of this. You will be doing 1 by infinity, 1 by infinity and 1 by 1. 1 by infinity is 0, 1 by infinity is 0, 1 by 1 is 1. So my dear, now you will write this number in the format of HKL without separating comma. 0, 0, 1 is the Miller indices. My dear, you can see when you are looking at the Miller indices, this include 2 zeros and single 1. 2 zeros and single 1. So my dear, once you are getting 2 zeros and single 1, for any plane, if you are getting 2 zeros and single 1, you will be finding out, my dear, the area of such planes is nothing but A square. You can see the area of plane ABCD is A square. So my dear, for any such plane, you will be getting the area to be A square only. So my dear, now if you want to find out, let us find out now the Miller indices for some other plane. Like let us consider the Miller indices for EFBA. I am showing that on the other slide. As you know, Miller indices are defined as rationalized reciprocal of fractional intercept in the 3 crystallographic axes 3 crystallographic axes. So my dear, let us see that. If you see that plane AEFB, if you take plane AEFB, if you see the plane AEFB, my dear, then you will be knowing that AEFB for x-intercept, this is the plane, x-axis is going like this. This is the plane, x-axis is going like this. Can you feel it? It is going to be parallel to each other. So guys, this time I am telling you the Miller indices for this plane. For the next plane, I will be giving you that you will be doing in front of me. So this is the case I am doing it. Just look at it once again. Then for the next plane, you are going to find out. So my dear, for this plane, you know x-axis is going like this and plane is going like this. So they are going to meet at infinity because they are parallel to each other. So I will be writing the x-intercept to be infinite. Yes. If you see the y-intercept, yes, y-intercept is going to be at this point and this point, that is A we are taking it as 1. So y-intercept is going to be 1. If you see, my dear, the z-intercept, if you see the z-intercept, once again you will be finding out that plane is going out like this, z-axis is going like this. So they are again parallel to each other. So my dear, you will be writing it to be infinite because two parallel things are meeting at infinity. So reciprocal of infinity, reciprocal of 1, reciprocal of infinity, it is going to be 0, 1, 0. You can see once again 2 zeros and 1 single 1. The area of such planes is a square. So my dear, now I am giving you one plane and for which you are going to find out the Miller indices. Let us see how many of you give the correct answers. My dear, now I want you to find out the Miller indices of the plane, this one. I want you to find out the Miller indices of this CBFG. You need to find out for CBFG. Plane CBFG. I want you to find out the Miller indices for that. I will not be finding out that. You will be giving me the answer. Let us see how many of you give the correct answers, guys. Let us see how many of you give the correct answers. Bharat, hello dear. Very good. Vishal Zala have answered it 100. Vishal Zala have answered it 100. Yes. When you will be having this plane, it is cutting at 1 at x-axis. So obviously it is going to give you the answer as, very good. J Kumar also is correct. The answer will be 100. This is going to be the Miller indices for this plane. Very good, Gaurav Vajpayee. And the area is a square because there is a single 1 and 2 zeros. So wherever you get single 1 and 2 zeros, area is going to be a square only. So it is very much correct. The area will be a square. Very good, Abha Maurya, GR Giri. Very good. All of you answer is correct only. Yes, wonderful guys. Wonderful. So the answer will be coming out to be a square for this case. No doubt about that. Yes, area is a square. Very good. Good, great guys. So this is how you find out the Miller indices. Now I am showing you the Miller indices for some different planes. Let us take this time the plane which is slightly different. The plane I am taking is this time AFGD. The plane is AFGD. If you see this AFGD, if you are going to take this plane as AFGD, then my dear, I am writing it to be again, this is rationalized, reciprocal, intercept in X, Y and Z. Okay, so guys, let us see what we are going to get. And this time the plane is, you know that, plane is AFGD. This plane cuts X-axis at A, cuts Z-axis at A, and it is going parallel to the Y-axis. So my dear, A we are taking as 1. So you know intersection at X is going to be 1. At Z is going to be infinity. At Z is going to be 1. At Y it is infinity. So my dear, reciprocal of this will be 1 by 1, 1 by infinity, 1 by 1. It is 101. So you can see, my dear, this time 2 times 1 and 1 times 0. So if you have any such plane which is having 2 times 1 and 1 times 0, 2 times 1 and 1 times 0, any such plane, they will be having the area to be equals to root 2a square. So this is second category of planes. There are 3 categories. We have seen the second categories. Okay, very good guys, very good. Abha, Jay, Anurag, very good. Good morning Minalo. Yes. So guys, wonderful. This is the second type of plane, CBFG. Halaki guys, for you only the paper will be asking you only to find out Miller indices. Okay, it is root 2a square obviously. And guys, now let us see the third type of planes. The third category of planes I am showing you is nothing but the plane DEG. The plane DEG. So when you are going to see the plane DEG, my dear, when you are going to see the plane DEG, when you are going to see the plane DEG, we will be having once again the three things: rationalized, reciprocal, of fractional intercept in all the three crystallographic directions. Okay guys, yes, we are going to see that. Very good. So my dear, if you see this, the previous slide, you know x intercept, y intercept, z intercept all are 1 1 1. So we will be writing it like 1 1 1, 1 by 1, 1 by 1, 1 by 1, 1 1 1. So 1 1 1 is the Miller indices. And for all these types of planes, the area will be root 3 by 2a square. So my dear, this is how we will be finding out the Miller indices and their areas. Thanks Minalo for your wonderful words. Yes, area will be root 3 by 2a square. Very good guys. So my dear, this is how we are going to find out. So now the point is, my dear, when Sir Miller was giving the presentation about this, so one of the person from the listeners have asked about the Miller indices of some different plane, and he asked from Sir Miller's that, sir, what will be the Miller indices for plane EFGH? I am making this plane separately so that you can have the better idea. So my dear, now I am telling you the challenge what Miller's got. The challenge what Miller got, and you may get the question from this challenge only. So just look at it. Just look at it. I am making the unit cell once again for you. Yes. This is the unit cell. This is my dear x-axis. This is my dear y-axis. And this is my dear z-axis. So if this is the three axes I have already shown to you. And let us say this time I am interested in this plane. I am interested in this plane. So my dear, I will be writing A, B, C, D. EFGH. So this was a challenge what Sir Miller's got for the first time. My dear, he was finding out rationalized, reciprocal, of fractional intercept in three crystallographic axes. Yes. So when he started finding out the Miller indices for this case, my dear, you can see, if you see the intercept, generally student says, sir, intercept over x-axis is 1, intercept over y-axis is 1, and intercept over z-axis is 0. But guys, you are wrong. Because if you see from 0 to 1, every point is the intersection point. If you see from 0 to 1, every point is the intersection point. So for x, if you say, the intersection point will be 0 to 1 every point. For y, 0 to 1 every point. For z, it is 0. So when you are going to divide 1 by 0 to 1, 0 to 1 are infinite number, you will be getting something indeterminate. 1 by 0 to 1 is something indeterminate. And 1 by 0 is nothing but infinity. So my dear, indeterminate, indeterminate, infinity. This itself, everything is indeterminate. So my dear, this time the Miller indices are coming I infinity. So it is not a valid number, because by looking at this number we cannot write, because number of ones and number of zeros are not at all clear here. So we cannot write the area of the plane. So my dear, always have the indication. If 1 0 2 1, area is root 2a square. If 3 1, area is root 3 by 2a square. If 2 zeros and single one, area is a square. But my dear, if 2 indeterminate and 1 infinity, you cannot write the area. This time we cannot even write the area. We cannot even write the area, my dear. So by looking at this, we are not very much clear. We cannot write the area of the plane. So my dear, because of that, obviously some doubts will be coming. So at that time Miller was helpless, and Sir Miller have thought that what we are going to do is just giving a number to represent which kind of plane it is. Means if that indication, if you are talking about plane ABCD, plane EFGH, both are parallel to each other. So he was knowing that both parallel planes have the same areas. So he was knowing that whatever he is giving is just nothing kind of physics is much associated with that. It is just a mathematical number. It is not going to have any relation with the chemical properties. Okay. Yes, dear, we will be taking, we are having session over properties. Even in one class, we will be having a discussion over electron, atom, nucleus. That discussion is there, okay, and that we are going to have in this series only. First of all, I am teaching you these things. That is also coming in this week only. We are having class over that. So my dear, when we are talking about this kind of problem, and this kind of problem came, Sir Miller have given a very good, very easy solution for that. Sir Miller said that when this kind of situation arrives to you, you just do one thing. Just change the location of origin. He said just change the location of origin, because Miller indices just tell you the type of plane, nothing technical in that. So guys, he said just change the position of origin, but you can change the position only once for one case. Like for finding out the Miller indices of EFGH, I can change the origin for once, not more than that. And that shifting should be such that the same problem shall not arise for the same case, and that shifting is going to be temporary only for this case. The original origin will be there only, but for finding out Miller indices for this case, you can shift the origin for some time. So my dear, let us change the origin, and I am taking the origin at point D, because once you are going to shift the origin at D, my dear, the same situation will not arise, because this time this will be x-axis, this will be y-axis. And if you are going to find out the intercept this time, you can see this intercept, if this is origin, this will become -1. So this time, my dear, the z intercept is -1. X and y axis are going parallel. So you know that this intercept will become infinite, this will become infinite, this will become -1. So 1 by infinity, 1 by infinity, and 1 by -1. It will be 0, 0 and 1 -1. And he have shown 0, 0, -1 as 1 bar. So my dear, if you see, the Miller indices are same qualitatively. 0, 0, 1 bar is showing the number of ones and number of zeros. Minus and plus doesn't have any importance. If you see 2 times 0, single time 1, the area will be a square, and you can feel the area is really a square only. So my dear, this was the solution given by Miller. You need to take care only about 2 things. One, this shifting of origin is temporary. It is not like we got now this is the new origin. No, origin have been shifted for this case, then once again origin will reach to its original position for the next case. Okay, and second thing, my dear, you just need to see the number of zeros and 1, whether it is -1 or +1, that doesn't matter. If number of ones is 1, number of zeros are 2, my dear, area is going to be a square. Hope you guys are getting this, guys. Please tell me. I have given you all the possibilities, but there are very less chance that examiner will be asking you about this. The reason behind this is because everybody will be shifting origin in different manner. You may get different answer based upon that. Okay, so that's why I said examiner will be giving you straightforward question when he will be asking you the Miller indices. He will not be giving you such kind of exceptional question. But it was my duty to tell you each and everything about this once we are discussing. So I have given you everything. Guys, now we are going to do the planar density calculation, and I hope you are very much clear. And guys, tomorrow, whatever the discussions we have made till this date, till today, we will be having some 8 to 10 problems over the topics we have discussed till now. Okay, whatever the discussions we have made, I will be having 8 to 10 questions in front of you tomorrow, where we will be looking at the Miller indices of some planes. We will be having the questions from volume density calculation, some previous year CSC questions, so that you can have an idea that how the questions are coming. So guys, this crash course will be continued in this wonderful way, and I feel all of you are enjoying this crash course. Okay, Yes. So for all branches, guys, it is mandatory subject, and I feel all of you are getting in a way that it is your subject only, because I am teaching in a very basic fundamental way that even that student can understand who have never seen anything about this. Okay, so my dear, this is something Miller indices. Now let us find out the planar density. So my dear, we need to do the planar density calculation only for BCC and FCC. So when we are going for planar density calculations, you know that planar density calculation was having average number of atoms, average number of atoms to the area of plane. This is what we know. So my dear, let us make a unit cell first. Let us make a unit cell first. Let us make a unit cell first. X, Y, Z. So if we are having, guys, this as a plane, if we want to find out the planar density of this type of plane, and you know this plane is if ABCD, you know, by looking at the plane we have just seen the Miller indices. And guys, I would even like to discuss some characteristics of Miller indices also after completing the planar density calculation. So my dear, if you see for ABCD, my dear, if you take the plane ABCD looks like this, and you very well knows that this is a plane for which Miller indices were coming out to be 0, 0, 1. 0, 0, 1 was the Miller indices for this. So 2 times 0, 1 times 1, so the area of the plane is going to be A square. So my dear, let us say if this is a BCC structure. If it is a BCC structure, then you know that there is no atom on the face. You will be having only 4 corner atoms, and for ABCD and 1 body center atom is there. For BCC, you know that for BCC you will be having corner atoms there, and there is 1 body center atom whose center will not lie on this plane. So my dear, we need to take the atom whose center is lying on this. Okay, Sambit Sao, we will try that also, we will make that also. First of all, as actually XC paper have gone, so students are more interested to know the future examination which are coming. Okay, but on some day I will definitely work on your request in this month also. Okay, I am waiting just to come the result of GATE, then we will make a video over that also. Okay, so my dear, if you see this, you know that body center atom will not lie over this plane. Average number of atoms whose center of which center lies on the plane. Center lies on plane. So we need to consider only those atoms whose centers are lying over the plane, nothing more than that. So if you see, all these corner atoms will be having center present on these corners, means on this plane. So average number you need to find out, and you can see if we are talking about planar density. In plane, a sphere can be considered to be a circle. In plane, a sphere can be considered to be a circle. So my dear, if you take it as a circle, you can see 90 degree is covered in the plane. So obviously 1/4 of the circle is covered here, 1/4 circle covered here, 1/4 circle covered here, 1/4 circle covered here. So my dear, 1/4 of 4 atoms is covered. So average number of atoms is nothing but 1 coming out to be. And area of plane you already know is A square. So you know the density of it going to be 1 upon A square. So my dear, this is how the density calculations are made. Okay. So my dear, when you are going to see the face centered, this was for BCC. If you are going to have FCC structure, for face center, you know my dear, that 1 atom also lies at the face. So if you are going to see, in that case, you will be making 1 face center atom that time, and 4 corner atoms as it is. So this time you know that 1/4, 1/4, 1/4 and 1/4, and this complete atom will be there. So this time if you will be finding out the average number of atoms, guys, it will be 1/4 into 4 plus 1. So it is going to be 1 plus 1, it is going to be 2, and the planar density is coming out to be 2 by A square. So my dear, this is how we calculate the planar density. And my dear, as I say, they will be asking you the planar density. Sunshine, no, it is not the first class, dear. It is already 4 to 5 classes have been there. But yes, you can understand as it is independent topic slightly. Okay. So you can understand easily, but obviously if you want to attempt it completely, 4 sessions are already been over. So my dear, this is how we will be finding out the planar densities. This is how we will be finding out the planar densities. So my dear, hope you are very much clear about the planar density calculations. And guys, likewise we can calculate for other planes. So now I will be showing you the table straight away, because as I said, if you will be knowing the planar density at different planes, the question will be directly asked to you. Even you can find out in this way if you want. Okay, but as I said, this is how you will be finding out average number of atoms whose centers are intercepted and the area of the plane. Okay, so my dear, when you will be going for all the types of planes, then you will be having this kind of table. I am showing you this kind of table. So when you will be finding out for these 3 types of planes, you will be getting these as the planar density, 1 by a square, 2 by a square. This we have just calculated. And my dear, for 110 it will be 2 by root 2 a square. For BCC, FCC it will be coming out to be same only. And when you will be finding out for 111 plane, you will be getting this as an answer. So my dear, as it is a crash course going on, so I am not going for calculation of each and every one. It will be just wasting of times, because in paper you will be, I feel, remembering only, because every time it is not easy to calculate. But yes, if you have proper idea, you can calculate also. So guys, you tell me whether you want calculation for other cases also, or straight away you want to have this table, because I have shown you how it is calculated. If you want, I can show you 1 to 2 more cases. Let us see about the plane which is 110. For 110 plane, if you will be having, the plane will be coming out to be like this. Okay, I am making the unit cell and I will be taking for BCC and FCC. I will be taking it for BCC and FCC. Okay, I am showing you one more so that you shall not have in mind that sir is saying us to mug up. I am not saying that to mug up. Even in course, I have calculated all the things. Okay, students, remember that. So this is ABCD. If here also you will say, I will be deriving each and everything, EFGH. So my dear, when you will be having this time I am talking about the special plane which is having the Miller indices of 110. This is the special case. Okay, and for this, if you are going to find out the Miller indices, for BCC, obviously body center atom will be lying over it and corner atoms will be as it is. So this time if you are finding out one complete atom is this one, 1 by 4, 1 by 4, 1 by 4, 1 by 4 is this one. So average number of atoms will be 1 plus 1 by 4 into 4. And planar density will be coming out to be 2 by, this time area is root 2 a square. Hope you all are getting. Yes guys, wonderful. If you want to see for FCC guys, this time you will be having the corner atoms as it is for sure. And you know that face center atom will be having half below this line, half above this line. Okay, so that half which is below this line will be coming like this. Half below this line will be coming like this. So my dear, half atom, 1 by 4, 1 by 4, 1 by 4, 1 by 4. So when you will be finding out the average number of atom, it will be coming out to be half into 2 plus 1 by 4 into 4. The atoms are 2 and density is again coming out to be 2 by root 2 a square. So guys, please tell me, are you clear about all these calculations or not? So guys, after doing this whole calculation, you will be getting this table. And this table is showing you the planar density for different planes. Guys, for paper 1, how to find Miller indice is more important. And for technical paper, density is also important. So for paper 1, density calculation is not that much important. Okay. But they will be asking you that the plane which are having maximum density, what are those planes and what is the name of those planes. That will be asked in paper 1. So my dear, I would like to say that if you see this table clearly, you can find out the density to be maximum. The density to be maximum for which type of plane, if you find out. So my dear, when you will be finding out that it is coming out to be root 2, it is coming out to be 4 by root 3. This is coming out to be 4 by root 3. So my dear, when it is 4 by root 3, if you will be finding out, the density will be maximum here for BCC and maximum here for FCC. Maximum here for FCC. Okay. And it is not root 3 by 2a square. It will be coming out to be basically the atom is 1 upon root 3 by 2a square. This you will be getting here. Okay. So the density is found to be maximum for BCC for this plane, for FCC for this plane. So when you will be getting this type of case, that when the density will be maximum here, so I just want to say, okay, by calculation also you can see which one is more. Don't worry about that if you want. I am telling you that whatever we have written here, if you see this table properly, you can see the density is different for different planes. The density is different for different planes. So out of this, my dear, the plane which is having the maximum density, that plane is said to be closely packed planes. Like my dear, let us say you are having one room in your hostel. That one room is having 3 students. A similar one room is there in your neighborhood. In that room there are 5 students. So you will be saying that room is closely packed because number of students are more in that room than your room. So my dear, comparatively, if some plane is having more atom, it is said to be closely packed planes. And in closely packed planes, if in a room there are 3 students, they will be far away to each other. If you are having 5 students in the same room, my dear, the distance between the students will reduce. So obviously in closely packed planes, the atoms are closer to each other. When atoms are closer to each other, my dear, obviously as 2 atoms are coming together to each other, there will be some repulsion. So some repulsion will be coming. So because of that repulsion, my dear, instability will be there. So my dear, to become stable, these planes always try to move their atoms. When somebody is unstable, it wants to be stable. So my dear, like if you are not feeling stable in your company, you will try to switch your job. So my dear, similarly, those atoms in that plane are not feeling stable. So they will try to be stable, and for getting stable, they will be moving. So it is very easy for the atoms to move along these planes, and that's why these kind of planes are also known as slip planes. Okay guys, so these kind of planes are also known as slip planes. So as I said, my dear, the highest density planes in BCC and FCC individually are said to be closely packed planes or slip plane. So the question in ESC paper 1 will be the planes which are having highest density of atoms are said to be. You will be saying, sir, those planes are said to be closely packed planes or slip planes. I am writing their name, closely packed planes or slip planes. They are said to be closely packed planes or slip planes. Closely packed planes or slip planes. Closely packed planes or slip planes. Okay guys, hope you are getting it in wonderful manner. Closely packed planes or slip planes. Okay, so these are closely packed planes or slip planes. Hope you are getting it in a nice manner, in a wonderful manner. Okay guys, yes. So closely packed planes or slip planes. Now my dear, after getting to know about slip planes or closely packed planes, now we are going to move further. So my dear, now I am going to discuss the characteristics of Miller indices. And guys, once you know about the characteristics of Miller indices, you will be getting a number of questions from that. And tomorrow you are going to see those questions. Just be ready for that. And this is the last topic for today. So daily 1 hour dose for paper 1 we are giving you, and this 1 hour dose is going to make your selection easier in ESC paper. So just take this 1 hour dose daily from the side of Grade Up. It will be making your immunity strong to qualify ESC paper. Okay. So my dear, the very first point is when some plane is parallel to an axis. When some plane is parallel to an axis, its Miller indices on that axis is 0. You have seen it a number of times. You have seen it in a number of times. Like this ABCD plane, it is parallel to x-axis, parallel to y-axis. So Miller indices are 0 for x and y-axis. So you can see guys, if some plane is parallel to some of the axis, the Miller indices in that axis are 0. Second, my dear, is two parallel planes have quantitatively the same Miller indices. You know that we have just calculated for this, the Miller indices are 0, 0, 1, and for this, the Miller indices will be coming out to be 0, 0, 1 bar. So my dear, when I say qualitatively they are same, when I say quantitatively they are same, quantitatively same means the number of zeros and number of ones are same. Like here, one single 1 and 2 0, single 1 and 2 0. So when we say quantitatively they are same, the meaning is the number of zeros and number of ones are going to be same. So number of zeros and number of ones are going to be same. So my dear, number of zeros and number of ones are going to be same. These are the important points. Number 3 is if two planes, let us say if two planes H1 K1 L1 and H2 K2 L2. If you are saying these two planes are perpendicular to each other, then my dear, the condition is the product of H1 H2 plus product of K1 K2 plus product of L1 L2 must be equals to 0. So summation of these three products, when it is coming out to be 0, then definitely these two planes are said to be perpendicular to each other. I am showing, my dear, everything whatever I teach is you. Whatever I am teaching you, I am showing it properly to you. If you see here, this was the first calculations we have done. For plane ABCD, this is plane ABCD. For plane ABCD, Miller indices have 0, 0, 1. And my dear, the next, if you see plane AEFB, it is 0, 1, 0. And you can see that AEFB and ABCD are perpendicular to each other. One plane is this, other is this. So obviously one plane is this, other is this, they are perpendicular to each other. So you can check the reverse condition. Once you can see, for one Miller indices are 0, 1, 0, for one it is 0, 0, 1. So H1 H2 plus K1 K2 plus L1 L2 will be coming out to be 0 for sure. So my dear, H1 H2 L1 L2 plus K1 K2 is coming out to be 0 because they are at 90 degrees to each other. So guys, I have verified this to you. So this point I have already verified. The next point is, if you are saying the angle is theta between two intersecting planes H1 K1 L1 and H2 K2 L2, then cos theta will be given like this. Okay, cos theta is defined like this: H1 H2 K1 K2 L1 L2, then H1 ka square K1 ka square L1 ka square into that. Okay, the planes which are having low index number, the planes which are having low index number are far away. How I am showing you that? My dear, you know that if I am showing you a unit cell like this, if this is x-axis, y-axis and z-axis, you already know for ABCD the Miller indices are 0, 0, 1, 0, 0, 1. Now my dear, I am taking that another plane, that plane is PQRS. This is PQRS. And it is at a distance of a by 2. Okay, yes. So this distance is a by 2. If you see that ABCD plane is away from the origin, PQRS is near to the origin. But my dear, when you are going to write the Miller indices for the planes, you know it is rationalized reciprocal of intercept in the three crystallographic directions. So if you are going to write this, my dear, if you are going to write this, you can see in x-axis it is not cutting x-axis, x-intercept is infinity, y-intercept is infinity, z-intercept is a by 2 means 1 by 2. When you will be taking reciprocal, you will be getting 1 by infinity, 1 by infinity and 1 by 2 will be 2. So 0, 0, 2 is the answer. So my dear, for red plane it is 0, 0, 2. For black plane it is 0, 0, 1. But you know that 0, 0, 2, 2 is bigger than 1. But red plane is quite near to the origin. So my dear, the planes which are having Miller index number lesser are far away from the origin, because reciprocal is making this thing. As reciprocal is there, so the planes which are away, Miller index are less. The planes which are near, Miller index are more. So this is how. And if you want to find out the distance between the distance of one plane from the origin. So my dear, if you want to find out the distance of a plane from the origin, the formula for that is d is equals to a divided by h square plus k square plus l square. So if you know the Miller indices of any plane, you can find out the distance of that plane from the origin, and this distance is said to be interplanar distance. This is said to be interplanar distance. Like if you want to find out the distance of a plane 1 0 0 from the origin, putting 1 0 0 you will get a. If you want to find out 2 0 0, it will be coming out to be a by 2. 3 0 0 you will be getting a by 3. So my dear, you can find out the distance of any plane from the origin using this formula. So guys, now I want a frank review for this lecture. I want to know whether you get the concept of the planar density and Miller indices or not, because if you got it, it is wonderful. And my dear, if you have any doubt, please ask, because this was the today's topic. Then I will give you a quick revision in 5 minutes and then I will leave the session. So a quick revision will give you a very good revision which is required, because a quick revision will make your task easy. You need not to revise by your own. I will be revising for you in 5 minutes. Please tell me first whether all of you got this or not, because tomorrow I will be teaching you the Miller indices for directions. Today we have discussed Miller indices of planes. Yes. So please tell me whether all of you got it or not. I want the answer in yes or no. Please tell me. Yes guys, if you got it, you can type Y also. Y will be fine. If you didn't get anything, you can ask me that topic, that particular instant. Yes, Y or no. Fine, Vishal. What about others? Very good, Jay, Dhaneshwar. Fine, guys. Fine, guys. Let us move further. So guys, I am revising the thing now what we have discussed from the starting. This was the very first thing. We have started Miller indices by telling you the planar density, and I told you planar density is given as average number of atoms whose, this is very important, whose centers are intersected by the plane. If the plane is not intersecting the center, it simply means that that atom will not be counted. And we will always be finding out average number of atoms means only that part of atom which is present in the plane will be counted. Then my dear, it is area of plane. It is area of plane. And guys, today at 2 p.m. I will be there in the Udan series, our ISRO DRDO session. You know, it is going on the Mechanical Marvels channel. And today we will be having the questions from Theory of Machines and Machine Design. Hope you guys will be there to solve the problems. And also at 1 p.m. you can join me today for the problem session over Theories of Failure over GradeUp app. And guys, from day after tomorrow I will be starting a free series over GradeUp app for the practice sessions of paper 1. There I will be discussing the questions as well as a quick revision of the topic, and then we will see some questions over the project management topic. Okay, and material science. 2 subject series I am taking. Okay, and if you will be giving good response, I will go for it for all the subjects of paper 1. That will be a capsule course for you. Okay, yes guys. So my dear, then I have shown you that in a unit cell there are number of planes. There are different types of planes. So this type of plane where the area is a square, another type of plane where the area is root 2 a square, the third type of plane where area is root 3 by 2 a square. So guys, these are the 3 types of planes where areas are a square, root 2 a square and root 3 by 2 a square. So when you are going for the planar density calculation, Miller indices are defined as the rationalized reciprocals of fractional intercepts. And my dear, rationalized reciprocals of fractional intercepts rationalized reciprocal of fractional intercept taken along three crystallographic directions, and they are written inside without a separating comma. Without a separating comma. Okay, my dear, and they are always expressed like without separating comma in the small bracket. And my dear, based on the number of zeros and ones, the areas and densities are there. So if some plane is having single 1, 2, 0, its density will be same. For any plane which is having 2, 0, 1, 1 as notation, the density is going to be same. So we have categorized it into three types of plane. One is having triple 1, other is double 1, one is single 1. So for three types of planes, we started making how to find out Miller indices, and we have finded out the Miller indices for various cases. Then I have shown the exceptional point here and how to move on for this type of exceptional point. We have seen that when we got indeterminate and infinity, we will be shifting the origin, and the shifting of origin will be such that you shall not get the same problem again. For once you can shift for one case, and that shifting is temporary. For other case, the origin will again come back to original position. Then my dear, we have found out the planar density calculation for some of the cases, okay, and like we have found out it for BCC, FCC, for ABCD plane, and then also for one more plane we have calculated. Then we have seen the characteristics. When a plane is parallel, its Miller indice is going to be 0 on that axis, and if you can see two parallel planes will have quantitatively means number of zeros and number of ones. Number of zeros and ones will remain the same. Then my dear, two planes having this one Miller indices, for them, if they are perpendicular, it will be coming out to be 0. This is the cos theta, and the planes having low index number are going to be far away from this. Okay, so my dear, this is how we have seen the interplanar distance. Guys, just remember this formula. Tomorrow we are going to have numerical from this, and my strong intuition says that you will be getting a question from this. My strong intuition says that you will be getting a question from this in the ESC paper 1. So guys, be ready for this type of question. Okay, hope you will be getting it. This is how we find out the interplanar distance. Okay, my dear, and then we have completed it. Okay, fine. This is the table which is giving you the density. Then I told you the plane with maximum density is said to be closely packed planes or slip plane, and slip is nothing but the movement of a group of atoms which is said to be dislocation. So my dear, this is how we are going to do. And guys, don't worry, as I said, we will be having the class over electrical properties also. Every part we are covering, so everything will be covered. So guys, I feel now we shall leave this session because already we have discussed, and 1 hour dose is going to be completed now. So tomorrow once again at 11 AM we are meeting for some numericals, some questions of paper 1 type, and Miller indices for directions we will see, and we will see linear density calculations. And guys, we will be having a discussion further over properties day after tomorrow, and in this way the series will go on. Goodbye guys for this session. Thanks for joining again.